Hello, Kanika. How are you?
Hello. Hello.
Hello, can you hear me?
Yeah, I'm able to hear you. Hi, how are you?
Good, good. How was the traditional?
Yeah, everything was good. So we had a long break, I think so.
Mhm.
EPC. So it's been a long time. Just give me a second. Let me connect. Yeah, so we were talking mainly about VPC, right? So, some last topics are left in VPC. Okay, today we'll complete all the theoretical part of VPC as well as the first lab that I was talking about. That was creating VPC and connecting it with internet. Okay, this lab we will do today, right? And the topics that are left now in VPC is security group. Another topic that we have to take is today is NACL. The third topic we'll deal about the difference between security group and NACL. Then fourth, we'll talk about VPC peering. And the fifth topic that is very much important as comparatively we talk about interviews is transitive peering. So only this much theoretical part is left in VPC. Okay. So have you gone through the previous lectures we have covered with VPC? Hello?
Yeah.
Yeah, you have gone through the previous lectures we have covered in VPC.
Uh-huh.
Any doubt you have till here? Because we have to start with the start and continue with this only.
No, I don't have any doubt. I just um like there are like real scenarios. Like for example, in the test, they ask like for example, okay, so the client want to something need something like need something from the BPC. I don't know. What will be um, something that you can offer reliable, less cost? Then I mean, I have to think about those scenarios like, okay, which one the client need the most?
So these questions are real-time queries you have, no? Real-time.
Real time, yeah, real scenarios.
So that will be solved in the lab. Okay. As we go to the lab, we will take there are three conditions majorly. When we talk about VPCs, there are three conditions. Okay. One is directly connecting VPC and accessing the internet through the VPC. Another is the peering concept and inter-region peering concept. So if you cover all these three labs, you will get a complete idea like how you can use VPC, how to use VPC, why to use VPC, and where to use VPC.
Yeah, okay.
You will be able to access the VPC.
But the fact is that when they ask me like a question, let me see if I uh, I have like a couple of questions that they might ask. Let me see. Let me see if I find one at least. Okay, so it's like the branch office in San Francisco and in Miami use site-to-site VPN connections to connect to the AWS VPC. The company is looking for a solution to have the branch office send and receive data with each other, as well as with their corporate headquarters.
Yeah.
So,
Example, the way you're talking about that, this is an one branch office A, branch office B. Two offices you have. You want that from branch A, the data can be sent to branch B, and the branch B data can be sent to A. Say this branch is in London and this branch is in India. You want this to do? You are saying this only?
yeah, and they want to send. They have like a VPN site-to-site connections, and they want
This
to
is only
send to each other
site-to-site connections.
with the
You are trying to
headquarters.
connect with the another site. So this concept is known as in cloud as inter-region connection. Okay, and in this lab we will see how we can connect two EC2 instances. One is in different regions in London, one is in another region, say India. And how can we create a, this is another VPC, this is another VPC, see VPC1 it is in, and this is VPC that is in India. How can we connect these two VPCs which are in different regions? And we can send the data as well as receive the data when these two EC2 instances are private subnets. Getting it?
Got it.
So we will learn all these things in the lab. So don't worry with this example. And any other example you have?
Yes. The the company wants to establish encrypted network connectivity between on-premises data center and AWS cloud. The company wants running fastest possible, and it should also support encryption in transit. So I just like got in the question.
Can you just share me this question? I'm not able to hear you clearly.
Let me see.
Yeah, just paste it in the chat box if you can.
Can I write it? Give me one moment. Just one moment.
A company wants to establish encrypted network connectivity between its own Mrs. Data Center and AWS. The company wants running fastest possible and should also support encrypted in transition. So see what you are trying to say. There is a company, okay. They have one premises here and one premises here, okay. Now they have some data inside this premises, right? First of all, they want to secure it, means encrypt it. This can be done using security groups. Or okay, once this is done, you encryption can be done using security groups. And now you just have to connect this EC2 instance, or you can say VPC, with another VPC. Okay, so inside a region also you can connect two VPCs together. So it is very simple. This lab also I will show you. I think so. This is lab number 2. We will see.
I don't know if you want me to get a couple of questions that I don't understand, like maybe later. I mean later, like maybe another day.
See, what we can do is, first let me complete all the things in the VPC part. Okay, maybe it's
Okay.
with the and the practical part. Okay.
Because if I
Yeah.
is that okay, I can learn how to navigate in the console, but when it comes with the test, I don't know how it's difficult for me to answer.
Yeah.
The right answer.
What I have planned for you is that let me just complete everything, the theoretical part and the practical part in VPC. Okay.
Okay.
I try to complete every possible example that real-time scenario has in the practical part. Still, you feel any of the theoretical questions or questions of real life, you can bring it to me and we can discuss them in the class. Okay. So your
Okay.
new questions will be solved and our theoretical and practical part will be solved. Both we can easily cover.
Okay, got it.
Got it?
Yep.
So let me just start with security group. Just try to understand what and when we are trying to integrate all these small components. So now just try to understand why security group is used, where we are trying to use the security group and how. Okay. So in security group, it is a virtual firewall, works at ENI level. Okay, let me just create a diagram for you so that it's easy for you to understand. So this red complete box you can say is a VPC, right? And this On this VPC, we have applied a lock called as VPN, right? Now we have one gateway here, one internet gateway, you can say. We have applied on VPC. This is the router we have. Okay, you can say this is a router. Now we have this as our route table. This is also a route table. Okay, this is your NACL subnet 1. This is your NACL subnet 2. Okay, this is connected with this, and this routing table belongs to this subnet. I told you every subnet should be connected with a routing table. Now this NACL is connected with this security group. And we have two EC2 instances here on which the security group is being applied. Okay, so this is our security group, another security group, another security group. This is our EC2 instance. This is also an EC2 instance. Okay, this you can say this is subnet 1 having 10.0.0.0/24 as its ID, and this is another subnet we have, subnet 2, that has 10.0.0.1/24. Okay, and this complete red box is our VPC, that is 10.0.0.0/16. Okay, this subnet is connected with this security group. Now this routing table is connected with this router, and this routing table is connected with this router. Okay, and this router is connected with this internet gateway. This router is also connected with this VPN. Okay, so now try to understand in this way. Okay, see, in this EC2 instance, individual EC2 instance, data is there. And on this date, EC2 instance, either individually, right? Here, on two EC2 instances, we have one security group. And here, on one EC2 instance, we have one security group. And on another EC2 instance, we have one security group. So, on either multiple security groups, you can on two same EC2s, you can apply one security group, or either on individual EC2s, you can apply a security group, right? Now each security group is connected with an subnet, right? And this subnet has its routing table here, and this routing table is being connected with the router, and router is connected with the internet gateway. This complete forms a VPC. Now, as we are talking right now about security groups, so what happens? Security group is a firewall, or you can say they are trying to secure the data which is inside the EC2 instance. Okay, they are acting like a firewall for the EC2 instances. Now, if we talk about here, that it is a virtual firewall that works on at ENI level. What ENI means is elastic network interface. So at the interface level, where we are trying to interact with the EC2 instances, at that level, they act as a firewall. Next, so up to 5 security groups per EC2 instance can be applied. Okay, so if this is an EC2 instance, okay, at this EC2 instance, this is your security group. So inside a security group, you can have 5 EC2 instances, means it is able to protect 5 EC2 instances, right?
Okay.
Another point, can only have permit rules, cannot have deny rules. This means, see, what happens sometimes, this is a port number, say port number 23 wants to come and access your EC2 instance, right? So you can allow in the security group that, okay, I am able, that if port number 23 comes to me, it is allowed that they can access my EC2 instance. Okay, but you can't say to the security group that if port number 23 comes, please don't allow them to access the EC2 instance. Okay, means you can just allow some port to access the EC2 instance, but you are not allowed to deny them. Deny policy is not given in the security groups. But if you don't mention anything, say you don't mention any port here, so it is automatically denied. So you have the ability to permit the rules that this port can access my EC2 instance, but you can't have the rule to deny it. That you can't specify that, okay, if port number 24 comes to me, please don't allow it to access my EC2 instance. You can't do this in security groups. Clear?
Uh-huh.
It is stateful, return traffic, of allowed inbound traffic is allowed even if there are no rules to allow it. So what I mean by stateful, first try to understand. Stateful means, say, okay, in this, what happens, security groups, I have applied 2 arrows. This is the condition of stateful. What stateful actually means, that if I'm allowing something to come inside the security group, this is known as inbound. That something from the outside is coming. So this is known as inbound. If I'm allowing that someone can come into my security group region, okay, if I'm allowing it, then I am also allowing that it can also send the data outside, that is outbound. So stateful means that if you allow inbound, automatically outbound will be allowed. Or vice versa, if you allow outbound, automatically inbound will be allowed. This condition, that if you're allowing inbound, outbound will be automatically enabled, this condition is known as statefulness. That's why we have applied two arrows that data can come inside and data can go outside. Both are possible. This condition is known as stateful condition. Okay.
Stateful condition. Okay. It's like, can you explain me a little bit better?
Yeah, see what you can do. This is a gate of an let me explain it to you. So this is a building, this is a house, okay, and this is a gate, okay. So if you're allowing a person to go inside the gate, right, this is known as condition of inbound, that you are allowing someone to go inside the gate. If you're allowing someone to go inside, then you are automatically allowing them to go outside also. So you are allowing someone to go in, so you are allowing them that at any time they can go out also. Or vice versa. If you are allowing someone to come out of the house, then you are also allowing them to get inside the house again. When we allow both in and out, right? If you are enabling inside, then automatically we are allowing them to go outside. This condition is known as statefulness.
When it can go inside and outside.
Yeah, both. If you are allowing them to get inside in the security groups says, if you are allowing them to come inside, then I'm allowing them that they can go outside also. This condition is known as statefulness.
Okay, got it.
Clear?
And stateless?
Stateless means that if you are allowing them inside, that doesn't mean that you are allowing them to go outside also.
Oh, okay.
Or if you're trying to them to get outside, doesn't mean that you are allowing them to get inside also. This is one way. This is both way. Clear?
Yes.
Security group. Security group is stateful. Just remember this. And if you talk about NACS, that is stateless. We'll talk about the difference. You will get to know that. Okay, clear?
Got it. Yes.
So return traffic of allowed inbound traffic is allowed even if there is no rule to allow. Means if you're allowing outbound in the security group, then automatically if you don't say that allow inbound, default it will allow the inbound also, because you have allowed one side. So automatically security group will, what will they do? They will allow inbound also. Okay.
Got it.
Now the next topic comes up. Security group is clear. Just remember, security groups works on EC2 instances. That above EC2 instance, if anybody wants to come, they have to cross the layer of security group. It is acting as a security here. Or you can say it is acting as a virtual firewall.
Are you talking about the different ports? There are like port 20, port 80, port...
Yeah. So anybody comes in that I want to access this EC2. First, they have to go to the security group and ask that is port number 15 allowed inside the security group. So they will check that is it allowed, then only they'll be able to access the EC2 instance.
So you're not going to talk about the different ports?
No, I'm not talking about different ports. I'm saying any request comes in.
Okay.
Consider it as a request that one of your client wants to access your EC2 instance, right, from the outside world. And this is a private EC2 instance. It is in the private subnet. Okay. It is inside the private subnet. Now someone wants to access it. So first they have to cross the security group wall. If this request is allowed by the security group, then only they'll be able to access it.
Okay.
Making sense?
Yes.
Great. network access control layer. This is known as, in short, NACL. So now we'll talk about this NACL. Now you can see the NACL in this diagram here. Just let me clear all the things. So let me get a clean diagram. Okay, now you can see this here. This is the NACL I'm talking about. Okay, this NACL I'm talking about, and it is inside this. Okay, so this has been removed. Okay, so I'm talking about this NACL. Okay, these two. Okay, now we have talked about security groups. Now it's time for NACL. Now what it is? So when we talk about it, it is a function implied router. So everything that is performed, every function that needs to be accessed inside the network access control, it will be through this router. This router is known as implied router. Okay, this is the implied router I'm talking about. So everything that is done inside the NACL, all the functions that are controlled by this implied router. NACL is an optional layer of security for your VPC that acts as a firewall for controlling traffic. See, whenever I talk about traffic, traffic means the number of requests that are being made. Okay? Hello?
Yes.
Traffic means the number of requests that has been made to get inside that router. Okay? So,
Okay.
traffic in and out of one or more subnets. Okay, so just try to understand, NACL is an optional layer of security for your VPC. Now, as I told you, this security group is a security layer for EC2 instance, right? But this NACL is a security level, security, you can say, security layer for your complete subnet. or you can say for a complete VPC, it is a security layer. So you can understand in this way that this is your house, right? This is your main gate, okay? And inside your house, there are multiple rooms. Say some room number, subnet 1, subnet 2, subnet 3, subnet 4. These are the rooms. Now, the security that will be on the main gate will be your NACL. Okay, so once you cross the main gate, after that you want to enter the rooms. So on the rooms, you have a security called security group. So if you want to get inside the rooms, you have to you have to cross the security layer of security groups. So this type of security is provided inside the VPC. Getting it?
Yes.
So in short, NACL is protecting the complete VPC.
Okay.
So that acts as a firewall for controlling the traffic in and out from one or more subnets. Your VPC automatically
But it's not. What about the router? It's not protecting the router.
sorry.
I mean, the NACL is not protecting the router.
See, inside the VPC, there is a router. See the diagram carefully. Inside this VPC, we have the router. If it is protect, here only we are securing the main complete VPC, so automatically router will be protected.
Okay, can someone hack a router?
Yeah, they can easily hack a router, but they,
Really?
yeah, they need to be very good at hacking it. See, nowadays you can hack any of the device.
Anything.
Any device you can hack which has internet connection. If your router is connected to the internet, right? Your Wi-Fi you're using in your house is a type of router. Okay.
Yes.
So they can easily hack your Wi-Fi.
Okay.
You need to enable multiple security levels to protect your Wi-Fi. Otherwise, it is very easy to crack the Wi-Fi password and they can use your Wi-Fi without knowing. And in the end of the month, you will say, I don't have used that much of Wi-Fi, how much my bill is coming so much. So it is very much possible.
But the company is responsible for that, right?
No, no.
I have to protect my Wi-Fi.
Responsible. Actually, what happens? Companies provide you with the router. Okay, they enable multiple securities in it. So the best company of the router will provide you with the best security, right? But they will never guarantee you that nobody can hack your router. Every security is just a, you can say, illusion. Because if it is secure, it can easily be broken. Right? Someone there is planning to break the security. If a company says that we have created the best router and nobody in this world can hack our router. Okay, so this is a one company who is challenging the people that nobody in the world can hack my router. Then there are 1,000 million people, or you can say 1,000 million hackers who are trying to hack this router. So no company does it ever.
Wow.
Getting it? So any
Yep.
device that is connected to internet is very much prone to get hacked.
Wow.
So your VPC automatically comes with a modifiable default network ACL. By default, it allows all inbound and outbound IPv4 traffic, and if applicable, IPv6 traffic. Okay, so your VPC automatically comes with a modifiable default network ACL. So there are two options you have. Okay, one, that a VPC already will have an NACL attached with it. That NACL will be known as default NACL. So in that default one, all inbound and outbounds for IPv4 traffic is already enabled. Another thing you can do, you can create your own network ACL. But when you create a VPC, as soon as you create a VPC, they will attach a default NACL with it. Okay, which will allow all inbound and outbound. Okay,
Okay.
default one. Now you can create a custom network ACL and associate it with a subnet. By default, each custom network ACL denies all inbound and outbound traffic until you add rules. So try to understand that you can create a custom network ACL. One I told you that one was the default one. As soon as you create a VPC, they will by default, they will create a NACL for you. Another option you have, you can create your own custom network ACL and associate with a subnet by default. So VPC you have created, to which you have attached a NACL, and this NACL you can easily connect it with any of the subnet. Try to see this diagram. VPC is created. With this VPC, you will get a NACL connected, and now you have to connect this NACL with any of the subnet. Getting it?
Yep.
Okay. Each custom network ACL denies all inbound and outbound traffics until you add rules. Means in default one, what was there? That all inbound and outbounds were allowed. But as soon as you create your custom NACL, you have to add some rules. That rules means you have to say, do you want to allow the inbound traffic? Do you want to allow the outbound traffic? So all the rules you have to give when you create your custom NACL. But in the default NACL, all the rules are automatically added. Getting it?
Can you repeat that? In the what? In the default in the default ANCL, all the rules are automatically added.
Yeah, already added. All the inbounds and outbound rules are already added. But when you create your own NACL, that is known as custom NACL, you have to add the inbound and outbound rules by your own self.
Okay, got it.
Each subnet in your VPC must be associated with a network ACL. If you don't, explicitly associate a subnet ACL, the subnet is automatically associated with the default NACL. So try to understand what they are saying. So each subnet in your VPC must be associated with a network ACL. Means we have two subnets. One subnet is this, subnet 1, another is subnet 2. They need to be associated with a NACL. Getting it?
Yep.
If you don't explicitly associate a subnet ACL, the subnet is automatically associated with the default NACL. Now suppose you have not attached, say, subnet 1 with any of the NACL. So what will happen? What AWS people will do? They will connect this subnet with the default NACL. Okay? Means all the traffic, all inbounds are on, all outbounds are on. Means anyone can access your subnet, anyone can send your to anyone, they can send the data. Okay? You can say this is complete open. No rules are added. But here you can allow that who can access your subnet and to whom your subnet can send the request. So this becomes more secure, but this is completely open. Clear?
Yep.
You can associate a network ACL with multiple subnet. However, a subnet can be associated with only one network ACL at a time when you associate network ACL with a subnet the previous associated is removed. So it is trying to say you can associate a network ACL with multiple subnets. Means this is an NACL. This is your subnet 1, subnet 2, subnet 3, and each has its security group, security group, security group. Now what is allowed inside the VPC? That you can allow and connect multiple subnets with NACL. Means in a single NACL, you can allow multiple subnets. This is clear?
Yes.
But one subnet should only be connected with one NACL. This is not allowed that you are connecting a single subnet, subnet 1 with NACL 1 also and NACL 2 also. This is not allowed. If you do so, say there's a condition applied that this subnet is connected with this NACL 1. Okay? But now what you did, you connected this with NACL 2 also. So what will happen? Automatically, this previous one will be removed. Now you can say the subnet 1 is connected with NACL 2. Getting it?
Yes.
Making sense, or I'll explain you again?
No, it makes sense.
Clear? The highest number that you can use for a rule is 32766. So when we talk about rules in NACL, so you can set from 1 to 32766 rules you can make. Okay, rules means rules you can take as a conditions, that which network you want to allow, which network you don't want to allow, right? Such rules. Say what happens that you have created rule number 1 in which you are allowing that at subnet 1 port number 2 can inbound. Okay. In rule number 2, you are saying, or rule number 100, you are saying that at subnet 1 allow port number 3 also. Right. Now in rule number 200, you are saying that in subnet 1 stop accessing port 2. So in this way, you can create rules till number 32766, means 32,766 rules you can create inside a NACL.
Got it. Okay.
Recommended that you start by creating rules with rule number that are multiple of 100, so that you can insert new rules where you need later. So what they say, that you are just allowed, means what they recommend you, that you create rules in the multiple of 100. Okay, why they say so that you can say you want to create a rule. So you can say I want to create rule 100, then I created rule number 200 and in the multiples of 100. Why? Because sometimes what happens, you have created rule number 100, say allow port number 30, right? And here you have said that allow port number 31 also, right? Now in between, if you miss any of the rule, so at rule number 101, you can add those rules later on. Okay.
Okay.
So to make it more flexible to you, and so you can change the settings of the NACL rules, so they allow you to be in the multiple of 100. It functions at the subnet level, means NACL works at subnet level, means see this diagram. Every NACL, you can see this NACL is connected with a subnet. So if you want to protect multiple subnets, so NACL will be the end layer of the subnets. Okay.
Okay.
NACL are stateless. Outbound traffic for an allowed inbound traffic must be explicitly allowed to. I told you what do you mean by stateless previously.
Yep.
So NaCl follows the stateless condition. You can have permit and delay rules in a NaCl. So you can, what you can do inside the NaCl, you can allow the permit rule also, you can allow the deny rule also. You means you can say that this rule number 20 I want to allow. This is also allowed. You can say I don't want to allow rule number 20. So you can do both permit as well as delay inside the NaCl. But you can't do the same in the security group, as we have talked about, right? So this NaCl is clear to you?
Yep. It
Now
is. It
let's
is clear.
now let's see the differences between NaCl and security groups. So security groups and NaCl. So when we talk about security group, it operates at instance level. This is clear that it works on it is a security group on EC2, so it works
Yes.
instance level. And NaCl, it operates at the subnet level. Clear?
Yep.
This point is very much clear.
Yeah, it's easy.
Supports allows rules only, means only you can select which rules you can permit. It permit allow as well as deny rules also. Means you can either deny also and you can access the permit also. Both you can specify inside the NaCl. Clear? This point is also very much clear to you.
Yep.
Security groups are stateful, that return traffic is automatically allowed. And in NaCl, it is stateless. Return traffic must be explicitly allowed by rules. Means if your inbound is allowed, then doesn't means your outbound will be allowed. For that, you have to add some rules. This is also clear?
Yep.
Security groups applies to an instance only, means this firewall works only on instance and applies to all the instances in the subnet. Okay, this is clear.
Yep.
So just revise the diagram again. In this NACL, if you are saying you're connecting with the subnet, okay, so all the security, all the instances that comes in the subnet will automatically be protected by NACL. But security group will provide protection to only those instances which are connected to it. Getting it?
Got it.
Everything is making sense to you? The
Yeah.
security
Making
group
sense.
and NACL both are clear?
Yeah.
Great. Now we have a next topic that is called VPC peering. So try to understand them in this way. So this is, we have a VPC A. Okay. This is one VPC A, which is in Mumbai. Okay. Inside this, we have created a EC2 instance. Okay. And this is a subnet. Subnet number is 24 subnets. Okay. This is another VPC, VPC B. It is in London. Okay. Inside this, we have an EC2 instance, and this subnet number is 172.31.0.8/24. This is our router we have, and this VPC we have connected with this router. This connecting of two VPCs, which are inside the two different regions, is known as VPC peering.
Okay.
Making sense?
Yep.
Now, if you want, okay, to send and connect this EC2 instance with this EC2 instance, how you can connect? Using VPC peering. If you will do VPC peering between two VPCs which are in different regions, you can send and receive both requests inside the different EC2s also. Making sense?
Okay. Yeah. You can explain site-to-site VPN.
Yeah, it's not, it's like different regions, means any site you can create. This is a site 1 and this is site 2.
Uh-huh.
So it is in different regions.
Well, the site-to-site VPN.
Yeah, this is site-to-site VPN only.
But
What site-to-site VPN means, when you are connecting two different VPNs together, that is only site-to-site VPN. Okay?
that is also site-to-site VPN.
Yeah, I'll explain you site-to-site VPN with more examples. Okay? Just try to understand first VPC peering.
Yeah, I got it. I
Got
understand.
it? So what VPC peering says? A VPC peering connection is VPC is considered one of the toughest topics of AWS. Okay, because it requires connectivities, right? So if you have any doubt little bit in your mind, okay, when we'll complete, just bring all the problems, okay?
Mm-hmm.
A VPC peering connection is a networking connection between two VPCs that enable you to route traffic between them using private IPv4 or IPv6 addressing. So what I'm trying to say, so if you consider this, that a VPC peer connection is a networking connection, which means we are trying to connect it to a network, and it is between two VPCs that enables you to route traffic between them using private IPv4. See, private word is very much important, because if this subnet, I'm talking about this subnet, if this subnet is public, okay, then it is already can easily connect with anybody in the internet, right? But what we are saying, this is not public, this is private, and this subnet is also private subnet. So if you want that two private subnets which are in different VPCs should connect with each other, This can be done using VPC peering. Clear?
Yes.
Instances in either VPC can communicate with each other as if they are within the same network. So, instances in either VPC, either means any of the VPC we are talking about, can communicate with each other if they are within the same network. Okay, what does you mean by same network? That they should be connected to this router. Now, as soon as two VPCs are connected within a single router, they create a layer like this outside this. And this layer completely is known as a network. So we can say this VPC A and VPC B are now in a single network. Getting it?
Yep.
You can create a VPC peering connection between your own VPC or with a VPC in another AWS account. The VPC can be in different regions. So try to understand it. There are multiple conditions you can create inside a VPC. So this is one VPC and this is another VPC. And both the VPCs are inside same region. So both are inside Mumbai region. This is VPC A. This is VPC B. Now what you can do, you can easily connect these two VPCs by applying the router. This is subnet. Inside this EC2 instance is there. Here also an EC2 instance is there. Now if you're connecting VPC A and VPC B, so this EC2 instance can easily connect with this EC2 instance. This is known as condition number 1. Okay. Now another condition comes up. This is another region. And this is also another region. Inside this, we have created a VPC. And inside the VPC, we have created and subnet. Okay. So this is London. Inside London, we have created a VPC. Inside VPC, we have created a subnet. And inside the subnet, we have an EC2 instance. This is, say, USA. Inside this, we have created a VPC. Inside this VPC, we have created a subnet. So this is our VPC. Say VPC number C, VPC number D. This is an EC2 instance. This is a subnet. Now, if you want to connect these two VPCs, you have to create a router here. And now these two regions can connect it with. Now, what is the beauty of this VPC? It says, if this VPC and this VPC, okay, you have created this, you have created in different regions. Okay, obviously this may, because it is different region and different account, this account belongs to Kanika. And because it is different region, this belongs to you, Alexander. Okay, this account belongs to you. So automatically we can connect because we are in different regions. This is clear?
Yep.
Now, one more condition which is provided by AWS is, this is a VPC. This is a region. And this is the same region we have. And you can say this is a complete same region. Okay. And in this region, you have this account. And you have let me create. This is complete one region. This is one account. This is another account. VPC here. VPC here. Inside this VPC, we have this account here. Inside this VPC, we have this account here. So try to understand this one. This is new. This is a region, say London. Okay. In London, we both have an account. So this is my account, my AWS account, and this is your account. Okay, your AWS account, right? Now, I have created a VPC in this account, and you have also created a VPC in this account. inside this VPC, we have created a subnet. Say VPC. Don't give a name because it is different accounts. This is your VPC. This is my VPC. We have an EC2 instance. Here also, this is your subnet. And this is your EC2 instance. Now, what AWS says, I allow the router here. Okay. I allow this router. Just give me a second. Okay? Hello?
Yes.
Yes. So now we want to connect these two VPCs together. So we have applied a router here. We have applied a router here. Now this router will, what this will do? This will connect this VPC with this VPC. So what we are trying to do in a single region also, if you have two different accounts, then also you can, with different VPCs, you can connect the and send your data from one EC2 instance to another EC2 instance. Getting it? So
Yes.
the same thing is written here. If you see.
Yeah, it's the same thing, you know, just understand.
Yeah. So you just try to remember all these things, because when interviewer asks, okay, they will ask you by giving the situations only, nothing else. They will ask you, they will give you simple situations and they will ask that is this condition possible or not possible. Okay. Or if I want to connect to such VPCs, what things I need to enable. So
VPC pairing.
yeah, you can create a VPC peering connection between your own VPC or with a VPC in another AWS account. This can be done in different regions also. I have given you example of a same region right now, that inside a same region, if we have two different AWS accounts, we can do this. And here is the example when they are in two different regions, then also you can connect. And if it is the same AWS account we are talking about, this is my AWS account and this is also my AWS account, then also creating two VPCs I can create. Clear?
What about in two different accounts?
Yeah, in two different accounts we have talked, right? This is two different accounts.
Mm-hmm.
This is two different accounts. This
Yeah.
is two different regions. This is in the same account. I'll write it for you.
Okay.
Account and same region, different region, different accounts. and same region, but different accounts. Making sense?
Yes.
Okay. Any doubt till here?
No, it's everything is clear. Everything is clear.
Great. Now we have one more situation here. Now the condition is known as transitive pairing. This is I from my side, this is very much important. They can ask you in your exam. Okay, I'm writing here important for it. So say you have a VPC here. This is VPC A. This is VPC B. This is VPC C. Inside this VPC, you have created a subnet, and subnet has one EC2 instance. Similarly, here a subnet, EC2 instance, subnet, and EC2 instance. Okay. Assume that this is in different region, this is in different region, and this is in another region. Okay, say it is in Mumbai, Delhi, London. Okay, and we have one router between the two, one router between the two. Okay, so this is a router, you can say router number 1. This is the router number 2. This is the router number 3. Okay, this VPC A is connected with VPC B. What does this mean? That the data which is inside this EC2 can be sent to this EC2. Clear?
Yes. This is like a star network.
Sorry?
Wait, what is? Okay, got it.
Okay. This router connects VPC B and VPC C, which means Now, the EC2 instance, which is inside the VPC-C, can connect with the EC2, which is inside the VPC-B. Okay?
Yeah.
This condition, what we can conclude then, VPC-A is connected with VPC-B, and VPC-B is connected with VPC-C. Okay? This
Got
is
it.
okay. Now, can we say that because VPC-A is connected with VPC-B and VPC-B is connected with VPC-C, what is trying to say that VPC-A is connected with VPC-B, VPC-B is connected with VPC-C. So just tell me, can we say that VPC-A is also connected with VPC-C? Is this possible?
Yep.
No, actually what happens, this is the, because generally what we learn is if A is equals to B, B is equals to C, then automatically A is equals to C, right? We learn this.
Uh-huh.
But in case of connectivity, this doesn't follow. This is known as transitive pairing. If A is connected with B and B is connected with C, it doesn't mean that the A and C are connected. Getting it? This
Okay.
is known as transitive pairing.
Got it.
I have given you this example so that you can remember it, that this condition doesn't follow here.
Okay.
Okay. One more example we can have.
But you can have a transit gateway and it is easier.
Sorry?
By having a transit gateway, you can connect all the three at the same time.
See, VPC, in VPC what you can do, you can connect two VPCs together when you do VPC pairing. Okay, maximum two VPCs you can connect. Inside this transitive also, you can connect only two. This VPC is connected with B, B is connected with C. Okay, but A is not connected with C, which means that here also you are only connecting A with the B and B with the C. Only two are involved.
Yeah, but what I'm saying is with a transit gateway, you can connect all the three VPC at the same time.
No, you can't. This is the concept of transitive pairing. Right? You can't say that if you are connecting VPC A with VPC B, okay, this is
In transit gateway, you mean?
see, I'll explain you.
It's like I understand the transitive pairing.
Yeah, I'm answering the question that you have asked, that can we connect three VPCs using transitive?
Transit gateway.
Yeah, I'm answering that only. So say this is VPC A. You have connected this VPC A with VPC B. Okay, this concept is known as VPC pairing.
Yeah.
Okay, and here also what you did, VPC B, you have connected with VPC C. This is also known as VPC pairing. Okay, now if you try to understand, and in a human mind we usually do this mistake, just try to clean it up from your mind, that this is Just a minute. This is VPC-A because it is connected. Seeing the first step, VPC-A is connected with VPC-B, right? VPC-B is connected with VPC-C. Seeing the second condition. So in our human mind, we conclude that, okay, these three are interconnected, but this is wrong. Okay? VPC-A is only connected to VPC-B, and VPC-B is then connected to VPC-C. Okay? They are not connected like this. They are not making any three VPCs connecting together.
I understand.
Now it is clear?
Yeah, I was talking about transit gateway.
Yeah, this is transitives only.
Maybe transitive pairing, but not transit gateway. In the transit gateway, you can connect even 3 VPC, and you can access to you can have a PPM connection.
Yeah, that is another concept.
Yeah, that was what I was trying to say.
That concept doesn't allow in this conditions. That follow another condition when we will talk about inter-region connectivity. There you can connect multiple VPCs.
Okay.
Is clear?
Yeah.
Okay. So I need to start with the lab, but the lab will is at least take 40 minutes more. So just see any problem you have, then we'll end the class. No. Actually, one concept is left. Just a minute. Yeah, this concept is left. So I was taught, we were talking about transitive pairing of different regions, right? Now same concept can apply in the same region. So this is one VPC. This is another VPC. This is another VPC. And this is the third VPC. Now, this is the region London, okay? The complete region is in London. Now, inside the same region, we have VPC 1, VPC 2, VPC 3, okay? Same router is here and the router is here. Now, inside this, we have a subnets. And inside each subnet, we have a EC2 instance. So this is subnet 1 and EC2 instance, subnet 2 EC2 instance, subnet 3 and EC2 instance. Okay. Now what happens? We are connecting this VPC1 with this VPC2, right, in the same region. So the region availability have been changed. Previously, what we were doing, all the three subnets were in different regions. Okay. Now here we can say all the three VPCs are in the same subnet and inside the same AWS account. Okay. This condition can also, they will ask you. Okay. And here also the same conditions apply. This is connected with this. Here also the same thing is VPC1 is connected with VPC number 2 and VPC2 is connected with VPC3. In the same account also, it is not allowed that VPC1 is connected with VPC3. Still in the same account, this condition is not applied.
Got it.
This is also clear?
Yep.
Any question you are getting in your mind right now?
Well, now everything is clear. Yep.
So we have seen the means the theoretical part of VPC is complete now. We have already complete all these topics today. Security group is clear to you? Any doubt in security group?
No. Everything is clear. Yep.
Difference between security group and NACL?
Yep.
VPC peering and transitive peering.
Yep.
Now see, we have a lab with us. Now I'll explain the lab right now only so that it will be easy for us. In this, we will create a VPC. Then we will create a subnet. Then we will create an internet gateway. And then we will create a routing table. After creating all the four things, we will connect VPC with subnet, subnet with internet gateway, and internet gateway with the routing table. Okay.
All right.
We will create a complete VPC system, and then we will connect it with the EC2 instance. So what we will do, we will connect this complete VPC setting into our EC2 instance, and we will create a web server. Okay, and in the web, we will check that is this VPC able to connect with the internet or not.
Got it. I have a question. How many hours we have left? Just want to make sure.
See, so I think 3 hours more we have now.
But okay.
So tomorrow.
What topics we can cover on the 3 hours?
See, in 3 hours we can complete our complete VPC, and we can start with the storage devices. Let me just check once more. So VPC demo is left and it takes hardly 40 minutes to complete. Then VPC NAT gateway will be left. So it will take 30 minutes, 1 hour, 10 minutes. And because see, I was trying to give you the lab of peering with regions. Peering we have understood right now, no? VPC peering. So I was giving you the demo of it, that how you can connect all the regions together, but you said no to them. So excluding the 2 labs, then we will have, so I'm not giving you the lab of peering, okay now. So then we will have NACLs inside my VPC, how you can enable NACL inside your VPC. That will take 30 minutes. So it will be 1 hour, 40 minutes. Then VPC endpoints, you have said you don't want the lab, and next 40 minutes we will require for VPC connection lab. VPN, then we will require it for VPN connection, 40 minutes. So 1 hour, 2 hour, 20 minutes we will require to complete VPC and VPN.
Okay.
Just write it on the screen for you. So it will take us 2 hours 30 minutes to take. 2 hours 30 minutes it will take to complete VPC and VPN. In VPC, only practical is left, and VPN also I'm just giving you the practical information.
Oh, that's included practical. 2 hours and 30 minutes. Okay.
Okay. So just let me know if you want to continue with the next topics that are EBS and EC2, all those concepts. EBS we will have, then AMI, EC2. I have shared a Excel sheet with you, right?
Uh-huh.
That much concepts will be left. So by tomorrow, hopefully I'll let you know. We can have a class of complete 3 hours tomorrow, and so
Okay.
we can complete our VPC, VPN concepts completely.
Okay. So we connect at 7 p.m.
Yeah, I'll let you know that.
Okay. Okay. Got it.
Clear?
Yep.
Okay, let's meet tomorrow. Please go to the sessions. I'll upload it by today. And if you have any issue, please let me know.
Okay. Thank you so much, Kanika.
Thank you. Have a great day.
Yeah. You too. Have a nice day.
Bye-bye.